In this PowerPoint, we're looking at statistics, in particular confidence limits and t-tests. So some of the symbols that you will see in this statistical sheet are N for sample size, X with a line above it for sample mean, and then the symbol that represents the standard deviation shown there. So what is standard deviation and how is it different to range? So standard deviation measures the spread of data around the mean value, and it is very useful whenever you're comparing consistency between different data sets. Range will give you the spread of data from the lowest to the highest value. How is it different to range? Standard deviation indicates, as I've said, the spread on either side of the mean. It traps 68% of all the values of the sample on either side of the mean. Now it's important to learn that. I have seen that question coming up where it's asked about how standard deviation is different from range or how does it compare. So do know that standard deviation tells you the spread on either side of the mean value and that it traps 68% of all the values of the sample on either side of the mean. If there's a lot of variability in the values, so in your sample you've taken a lot and there's been a big range of results, then the standard deviation value would calculate would be large. But if most of the values are around the mean value, then the standard deviation value will be small. Range is only telling you the difference between the lowest and the highest value. So why is standard deviation more useful than range? So as I said, range values only give you the lowest and highest values, but no information about the data between, so the overall variability is not known. With standard deviation, you are able to see the variability about the mean value. And as I was saying, if it's a large standard deviation, there has been a lot of variety of results. There's a big spread of data about the mean. If it's a small standard deviation, there is a small variation in the results. They're all very close to the mean value. Once you have been given the standard deviation, you can calculate the standard error or the standard deviation about the mean. And there is a symbol for standard deviation about the mean, the standard deviation sign, and then the mean sign. This value is quite often given to you in an exam question, and then you're asked to work out the confidence limits and see if null hypothesis is accepted or rejected. So on your statistical sheet, this would be to do with standard deviation of the mean and your confidence limits and what you would be calculating out. So the top one is how you can calculate out the standard deviation of the mean or standard error. So as you can see there, it is standard deviation squared divided by the number of sample, and then that answer is the square rooted. You're often given the standard deviation of the mean value, so then you're going to 2.2 to work out the confidence limits. So some of the symbols again, so X with the line across it is our mean value. The top one you can see is the same as above for working out your standard deviation of the mean. So it is exactly the same. So standard deviation squared divided by the number in sample and the square root of that. So this one below is showing you that you are doing the mean plus or minus to get the upper and lower confidence limits. The t value, which you take from the t table at p equals 0.05 and multiply that by the standard deviation of the mean. So here's an example question. So as I said, in the exam you may get asked about confidence limits and if the null hypothesis is accepted or rejected. So if we look at this question, so mosses of the genus Sphagnum are typically found in wet habitats with high levels of rainfall and poor drainage. The mean percentage cover of sphagnum was investigated at a number of sites on a mountain. The position of the sample sites is shown in the diagram below. So pause the video and see if you can state a null hypothesis for this experiment. So to write your null hypothesis, you hopefully have written something along the lines where there is no significant difference between the percentage cover of sphagnum and their position on the mountain. Any difference is due to chance. The mean percentage cover of sphagnum and for sample sites 1 to 6 is shown in the graph below, and their 95% confidence limits are included. The mean percentage cover of sphagnum in site 7 was 58%, and the standard deviation of the mean was 2.422, where n is equal to 25. So you have been given the standard deviation of the mean value there, and you've been told how many were in this sample. So using the information given and the statistics sheets provided, you've been asked to calculate the 95% confidence limits for site 7 and to show your working out. So here you can see in the statistics sheet, we have our confidence limits 2.2 for the population mean. And because we have been given the standard error or the standard deviation about the mean, we can use the bottom one in this calculation. The first thing we need to do is know what our t-value is. So to find the t-value, we need to work out our degrees of freedom. And the degrees of freedom is n minus 1. We've been told that n is 25. So 25 minus 1 gives us 24. And at p equals 0.05 on our t-table, we can see at 24 degrees of freedom, at p equals 0.05, that the reading is 2.064. So that is our t-value. Now that we've got that, we can now work out our confidence limits, our upper confidence limit and our lower confidence limit. So we are doing our mean value, which we were told was 58, plus or minus the t-value, 2.064, and our standard error, standard deviation about the mean value, which we were given was 2.422. So to find the upper limit, we will add the calculation, so 58 plus 2.064, the t-value, multiplied by the standard error value, 2.422, and that gives us an answer of 63. The lower limit, we take it away and we get 53. So our upper confidence limit then is 63, the lower confidence limit is 53. The next part of the question then asks you to complete the graph by plotting the mean percentage cover, which was 58%, and then the 95% confidence limits. So we put in our graph and we have our confidence limits drawn in. So looking at the results, can you write a conclusion stating if the null hypothesis is accepted or rejected? So when you're looking at your graph to see if the null hypothesis is accepted or rejected, you want to look and see, is there overlap between all of the confidence limits that you have plotted or that are on the graph? So if we take a number of positions along the graph, we can see that they do not all overlap with each other. So because there's no overlap with all of them, then we will reject the null hypothesis. We would say that there is a significant difference in the mean percentage of cover at the different sites on the mountain. The question then may go on and ask you to suggest reasons for why there is this difference in the results, and you could come up with a conclusion that at different sites and on the mountain, so for example sites 3 and 4, the very steep parts of the mountain, there's a lot of water runoff, and this plant is a plant that grows in wet habitats, so there isn't enough water for them to grow. So you would always look at the thread of the question, the start of the question. They would maybe have given you some information to help you with that. So here's another example. So a student noticed that the ivy leaves growing on the shady side of a building were larger than the ivy leaves growing on the sunny side of the same building. The student collected and measured the maximum width in centimetres of 30 leaves for each habitat. So using statistical analysis, can you work out to determine if it's likely that there is a significant difference in the leaf size between the shady and the sunny ivy plants with 95% confidence? So the first thing you're going to do is state the null hypothesis. So again, pause and see if you can write a null hypothesis for this question. So your null hypothesis should be going along the lines that there is no significant difference between the size of the ivy leaves growing in the shady or the sunny area of the building. Any difference is due to chance. The results that you have been given, you've been given the mean value for both sets of results, standard deviation, n, so how many were in the sample, and the standard deviation about the mean value. So using the information given and our statistics sheets again, calculate the 95% confidence limits for both sets of results and show your working out. So the first thing, as before, you're going to work out the t-value. So you can pause this and give this a go. Use your notes to help you, or use the t-table in your notes to be able to work out what the t-value is and then do the calculation to work out the upper and lower confidence limits. So if you pause the tape or pause the recording and give this a go. So to work out the t value, it is n minus 1 degrees of freedom. So n is equal to 30. So our degrees of freedom is 29. Again, at p equals 0.05. And when you look at that on the t table, you will see that the t value is 2.045. Okay, so if you see here, so we've worked out our t value. Now we're using our statistical sheet. So because again you have been given the standard deviation about the mean value, we can use the bottom row and we can use the bottom diagram. So for our shady leaves, calculating our mean value we've been given is 7.43 plus 2.045, which was our t value, times 0.30, and that gives us an upper limit of 8.04, and then we subtract it from the mean value 7.43 to get the lower limit. Same can be done for the sunny leaves. So if you haven't done the shady one, pause again and try doing the calculation for the sunny leaves. So for the results for the sunny leaves, you can see that our upper limit, using the mean value of 5.88, plus again our t value 2.045, multiplied by this time the standard deviation about the mean being 0.24, and there you get our 6.37 and 5.39 as the lower confidence limits. So again, you could be asked to draw this onto a graph, and you would be able to then from that, or even looking at the values, if you look at the upper and lower limits, the lower limit for the sunny leaves and the upper limit for the shady leaves, and you look at the values that there are, do any of them overlap? And if you look at the shady leaves, you can see the lower limit for the shady leaves is 6.82. The upper limit for the sunny leaves is 6.34. So from looking even at those two results, there would be no overlap between the lower limit of the shady leaves and the upper limit of the sunny leaves. And you can see this in this graph that there is no overlap. So again, will we accept or reject the null hypothesis? So because there is no overlap, then we will reject the null hypothesis. We would state that there is a significant difference at p equals 0.05 between the leaf size on the shaded and the sunny side of the building. So that is how we can do our 95% confidence limits. Our t-tests, these are used whenever you're comparing two means. So we could use a t-test for the previous one as well, but for use when we're comparing two means to see if there's a difference is due to chance or significant. So our t value and how we calculate it out is using this formula. So your mean from sample 1, take away the mean from sample 2. Then we have the square root of our standard deviation squared of sample 1 divided by the number in the sample, plus the standard deviation squared of sample 2 divided by the number. But again, you will quite often be given the standard deviation about the mean or the standard error value. So you would use the bottom equation there, where it is showing you the mean sample 1, take away the mean of sample 2, and then you're dividing that by the square root of the standard error squared of sample 1 plus the standard error squared of sample 2. And because we've got two samples, it is n1 plus n2, take away 2 to work out our degrees of freedom. So here's an example. The ear length of two populations of rabbits was measured. Use the t-test to determine whether there is a significant difference in ear length between the two populations. So you've been given the number that they sampled, the mean ear length, and the standard deviation or standard error of the mean. So our null hypothesis, what will it be? So again, pause. Can you write a null hypothesis? So our null hypothesis would be that there is no significant difference between the ear length of the rabbits in population A and B. Any difference is due to chance. So again, using our statistics sheet, then we can pick our correct calculation or formula to use. So because we've been given our standard deviation of the mean, we would use the bottom equation. So again, pause, and can you do the calculation? So our t-value is equal to 59 minus 58, the mean from each population A, take away the mean from population B, divided by the square root of 0.17 squared plus 0.10 squared, which were your standard deviation of the mean values, and that gives us 1.92. So what do we do with this? So our t-value, as I said, is 1.92. We are now having to work out how many degrees of freedom there are. So we had 15 in each sample. So 15 plus 15, take away 2, and that gives us 28 as our degrees of freedom. Looking at the 28 degrees of freedom at P, we can look to see, well, where does this t-value of 1.92 lie? So at 28 degrees of freedom, we can look and see that 1.92 lies between P is equal to 0.1 and P is equal to 0.05. Because when you look in the table there, at 28 degrees of freedom, at 0.1 the reading is 1.701, and at 0.05 the reading is 2.048 at 28 degrees of freedom. So because of that, we can then say that the p-value, so 0.1 is greater than the p, which is greater than 0.05. As it lies between these two. Okay, so as you can see there. Then you can be saying, well, am I going to accept or reject the null hypothesis? So because it is lying to the left of 0.05, we will accept the null hypothesis. Remember, if it's to the right, you reject. If it's to the left, you accept. And because of that, because we're accepting it, then we're saying that there is no significant difference between ear lengths of both populations, and any difference is due to chance. So whenever you are doing a t-test and you've calculated the t-value, you are often asked about where the value lies. So when you're looking at that, you're stating where it lies in between, looking at the table of the t-values. And that's why we've got the 0.1 is greater than P, which is greater than the 0.05. And then if it's to the left of P equals 0.05, you accept null hypothesis. And if it's to the right, you reject null hypothesis. So make sure you familiarise yourself with the symbols for the calculations. As I've said, you're usually given the standard deviation about the mean or the standard error value. So you would use, depending on what type of test you've been asked, if it's the confidence limits, you would use that second formula that's given in the confidence limits section, where it's the mean plus or minus the t-value that you would take from the t-table, multiplied by the standard deviation about the mean. Or if you're doing a t-test comparing two mean values, then again, you often are given the standard deviation about the mean value. So you're squaring each of them from both samples and then taking the square root of it at the bottom. So hopefully this will help with the confidence limits and doing t-tests.